In the previous unit, we developed a simple program for drawing squares. But now that we know more about procedures, it would be good to define a procedure to do this. This way, we can easily identify the part of our code that carries out this task, and we can easily reuse it too. This is the part of our code from the previous unit for drawing a square. Now let's create a new block for this in Scratch.
I'll name it Draw Square. We'll now move this code inside the definition of Draw Square. We could call the Draw Square procedure whenever we press the spacebar.
This procedure draws a square of a specific size, that is, where each side is 100 steps long. To make it more general, we could extend this program so that it asks what length we want for the square size, and it then draws a square of that size. It would be really useful to have a block draw square side and pass this value as data or as a parameter. Before implementing this, let's reflect for a moment. If you look closely at different Scratch blocks, you'll see that in certain blocks we can fill in some information. For example, in the Move block, we have to indicate the number of steps to move. This information that we need to include is called a parameter. A parameter is a value that is passed to some procedure. It is used to change a general statement, such as move X steps, into something more concrete, move 25 steps. Just like with the Move block, the new blocks that we define in Scratch can also have parameters. Now, going back to the case of drawing squares, we could create a block that has the length of the sides as a parameter, so as to draw a square of that size.
So we'll create a new block called Draw Square Side, and we'll click on Options and select Add Number Input. This helps us specify a parameter of numeric type. We'll call this parameter side length. Good. Now let's define what this procedure does. It is almost the same as the one for drawing a square, with the only difference that we now move a number of steps equal to side length.
You can see that this procedure for drawing a square is a generalized version of the draw square procedure. If you feel like it, you can also add some color effects, or you could change the pen shade or size to make the drawing even cuter. Keep in mind that when programming, there are in general several ways of implementing our programs. So you could have programmed this block in a different way, and your program could still be correct. To test the block, we can create a program that draws several squares, such as 3, so that they all have their top left corner at the same point, like this.
So we'll introduce a When Green Flag Clicks block, followed by a repeat block, setting it to 3 times. Inside this loop, we'll put a Draw Square Side block. But what side length should we specify? We could ask the user to specify this for each square, so we'll introduce an Ask block right before a Draw Square Side block, and use the user's answer as the side length. When we enter 100, we get a square with sides of length 100 steps. Similarly, if we enter 120, the square sides have a length of 120 steps. So the value entered as the answer is used as a parameter of the Draw Square Side block. In other words, the variable side length takes its value.
Number 2. When I was creating a new block, I put an extra parameter, but I don't know how to remove it. Do I need to delete the entire block?
No, that's not necessary. When creating the new block, you can see a cross above each parameter, and if you press it, you can delete it. If you've already created your block, you can right-click on it and select Edit to remove the parameter in the same way.
Sounds good.
We could extend our square drawing procedure to have additional parameters apart from the length of the sides, the X and Y coordinates of where we want the square to be located. Let's do this.
We'll create a new block, Draw Square Side Position, which has 3 parameters: side length, X, and Y. The first thing to do is locate the pen in the given position X and Y. Then we can draw a square with the indicated length for each side. We already have a procedure that does this, so we can reuse it by simply calling it. Now let's create a program that draws 3 squares that have their top left corner at the same point, like earlier. But in this case, we get to specify the position. For instance, we want the squares to be drawn at point 80 and 80. Let's test this one too. Excellent! If at any point you want to clear the stage from the drawings, you can use a clear block.
If we analyse the overall process that we followed for drawing squares, we can see that in the previous unit we created a first version of the program, which we modified in this unit using blocks, and we generalised it to draw squares of any size at any point. Generalising our solutions is a very good practice in software engineering, and it involves making our programs less specific to a particular situation or case, so that they can be reused in other scenarios. For instance, if we had an algorithm for boiling semi-skimmed milk, we could generalize it to describe how to boil any type of milk, or even how to boil liquids in general. In our case, when defining draw square side, we generalized our drawing square procedure to account for squares of any size. This was even further generalized to allow drawing squares at any point with the draw square side position procedure. We encourage you to follow an incremental approach when generalizing your solutions, just like we did in this video. It is also a good idea to reuse your code when doing that, similarly to the way we reuse the draw square side procedure when defining draw square side position. Now, how about generalizing our square drawing procedures even further? For instance, to draw shapes of any number of sides where all sides have the same length. We leave this as a challenge for you.